Hi friends, good morning to all of you. Welcome to Ram's Academy. Ram's Academy has released many videos in electronics subject and also in electrical. Today I am going to discuss about various types of diodes. When you take up a diode, I have to tell a story what was happening earlier in the history. Actually, in the year 1900 and all, they wanted to rectify alternating current for application of certain things to charge the battery and other things. Therefore, they were developing diodes. The diodes were made of vacuum tubes. I think the present students may not be learning, may not be having any idea about vacuum tube. Vacuum tube is nothing but there are going to be electrodes within a glass tube that is supposed to be an evacuated tube. Therefore, when they were manufacturing vacuum tubes, they were keeping 2 electrodes and 3 electrodes, 4 electrodes, 5 electrodes like that. Therefore, when they were using 2 electrodes within the vacuum tube, they called that as diode. Diode. Di means 2. 2 electrode means diode. Therefore, when they had 3, it was triode. 4 means pentode. 5 means 4 means tetrode, 5 means pentode, like that. They were manufacturing vacuum tubes using several things. Therefore, in the 1948, when transistors came out in the market, they wanted to manufacture rectifier component. That component was having 2 electrodes, 2 anode and cathode, like that. Then also they called it as diode only. Therefore, diode is a very, very important active device used in electrical as well as in electronics. That is what I am going to discuss today here. There are a lot of diodes, for example, to rectify alternating current which is available in the domestic power supply, that has to be rectified for some application to electronic equipments. Therefore, rectifiers were using only diodes only. Like that, when you go for communication equipments, there also certain devices are necessary using diodes. Therefore, the diode used for rectification, the diode used for communication equipment, both are to be different, with different characteristics, with different voltages, different internal characteristics, internal structure, and like that. There are a lot of diodes. That is what I am going to discuss today. About 11 numbers are here. Let me give out an explanation about a vacuum diode. See, for information, those who are not knowing anything about vacuum diode, I tell you, there are certain elements, when it is heated up, electrons are liberated from the final outermost orbit of the atom. Like that, within the vacuum tube, one electrode, when it is heated, it will be emitting electrons. Free electrons are emitted. They get more energy because of heating, they start liberated. Therefore, when a cathode is heated, electrons are liberated. That's called thermionic emission. That is called as thermionic emission. When they are liberated, what happens? If we have another electrode just above the cathode, and if we give a positive potential with respect to cathode, what happens is these electrons are having negative charge, and anode is going to have electrode, the top electrode is going to have a positive charge. Therefore, they are attracted and electrons start moving towards the anode terminal. Bottom one, which is heated, is called as cathode. The top one, which is going to attract electron, is called as anode. Therefore, electrons will be liberated and attracted by anode. Therefore, electrons cannot liberated by anode and attracted by the cathode. Therefore, electrons are going to flow in only one direction, but not in the other direction. Therefore, whenever anode is positive, it is going to conduct. Like that, this property only, vacuum diode was able to be used as a rectifier diode. This is about vacuum diode, which the people, for their information, I was telling about it. This heating effect is not necessary for a semiconductor type of diode. That is why it became very, very popular. The diodes, the cathode has to be heated. Cathode has to be heated. That needs another heating element, and they are supposed to be fed with alternating current or something. These things are not at all necessary for liberation of electron. Nothing is necessary in semiconductor type of electronic devices. Therefore, the semiconductors which we are using normally for manufacturing all the electronic devices are based on either silicon or germanium only. Therefore, let us go to the list. The first one is silicon. Therefore, semiconductor diodes are manufactured using either a semiconductor silicon or a semiconductor germanium. Therefore, for a diode has got a characteristics like this. When the diode is applied a positive potential to the anode and negative potential to the cathode, it will start conducting. Electrons will flow from negative terminal of the battery to the positive terminal of the battery. When anode is given positive and cathode is given negative, electron will start from cathode to anode and then it will complete the circuit. When you reverse the voltage, what happens is when you give negative voltage to the anode and positive to the cathode, definitely electrons are not going to flow from cathode of the battery to the anode. Therefore, in reverse direction, current is going to be 0. In the forward direction, current is going to be more. Like that, the conduction will be in the forward direction only. That is called forward bias. When it is not conducting, it is called a reverse bias. That has got a characteristics like these silicon diodes are going to have a characteristics as either forward as well as reverse bias. When you have a characteristics, VA characteristics like this, that is applied voltage and this is going to be the current flowing through the diode. Therefore, for silicon diode, either silicon or germanium, the diode in the forward direction has to raise like this and go up. Like that, this is going to start conducting. The silicon based diode or germanium based diode, it is going to start either from 0.2 volts or 0.7 volts. 0.2 volts for germanium, 0.7 volts for silicon. This voltage is called as cut-in voltage. That is, cut-in voltage is nothing but the voltage beyond which the diode is going to conduct. Or you can say that it is a contact potential. Contact potential should be overcome by the application of the voltage to the diode. That is 0.7 for silicon, 0.2 for germanium. When this is the case, when you are applying a negative voltage to the anode and cathode like that, the current is going to be minimum and then it is going to raise. So this voltage is called as breakdown potential. Up to breakdown potential, current is going to be minimum only. That means the diode is going to show very high resistance. Beyond certain voltage, the diode is going to be spoiled. That is, it is going to get short circuited. The current is going to be enormous. Therefore, this potential at which breakdown occurs is called breakdown potential. The current is going to be maximum. Therefore, this is the characteristics for either the diode manufactured using silicon as the semiconductor or germanium as the semiconductor. Only the difference is cut-in potential is going to be 0.2 for germanium and 0.7 for silicon. This we have to understand that. Like that, the diodes can be manufactured with these characteristics. Okay, fine. We are not bothered whether it is going to be manufactured for silicon or this thing. According to the application, we can choose that. But coming to the third diode, that is a rectifier. Rectifier, I have pointed out, rectifier is nothing but a diode only that is used for rectifying an alternating voltage to provide a DC voltage. Okay. Coming to rectifier diode, the purpose of rectification is this. Actually, for domestic power supply, we are going to get only alternating current. But batteries are going to supply only DC current, they are direct current. And unfortunately, all the equipments, whatever we use, like television, radio, or anything, they are going to work under DC voltage only. When that is the case, what happens is when you get AC, but your necessity is you have to get only DC only for these things, and you have to do something. We have to convert this into this. Therefore, converting an alternating current to DC is called rectification. It is rectifying the voltage into DC. Therefore, the diodes are used for rectifier only. The diodes, as I said, they are going to have two terminals like anode and cathode. But these are going to have these characteristics, whether it is a silicon or a germanium. Therefore, this conduction is possible when you apply an alternating current. that is going to conduct only the positive portion of the alternating voltage only. Therefore, when it is forward biased, that is, when this is positive with respect to this, it is going to conduct. When it is going to be negative, this is not going to conduct. Like that, rectification is done using a diode, either silicon or germanium. But only thing is, it has to take into account the cut-in voltage of the cut-in voltage necessary for a particular application. Normally, low frequency diodes means these diodes are made in such a way that they will be able to drive, and they will drive maximum current, and also they will work under low frequency like 50 hertz or 60 hertz, which are domestic power supply in India as well as in the United States, or low frequencies up to 1 kilohertz. These low frequency diodes can be used. These diodes are with the specification like 1N4002, 1N4007. This is 1N. Many people are mistaken. They call it as IN. No, it is 1N only. What is 1? 1 is nothing but diode. When 1 is written, it is diode. If it is written like 2N, that is a transistor. 2N means 2 junction, it's called as a transistor. Like that, this 1N, these diodes are silicon diodes only. They are meant for AC rectification. And there are diodes which are useful for high frequency rectification. The diodes are called as high frequency diodes. What for high frequency diodes are necessary? Okay, coming to high frequency diode, I have already pointed out certain diodes like 1N4002, 4007. These are called as low frequency diodes rectifying the 50 Hz power supply. There are certain diodes which will be useful for high frequency rectification in communication equipments. Therefore, when the frequencies are above 550 kilohertz, the diodes are supposed to be with different characteristics to rectify those high frequency component, and those diodes practically they are available as OA79, OA91. Like that, these are the diodes, germanium diodes, which are used for rectifying the high frequency above 550 kilohertz. Normally, for example, in AM demodulated circuits, they are made of germanium because they have to rectify starting from 0.2 volts. If you use a silicon diode, it will rectify only from 0.7. Here, there may be certain information between 0.2 and 0.7. Therefore, only germanium have to be used. Like that, these diodes are useful for high frequency rectification only. High frequency rectification in communication equipments. And then coming to okay, fine. After this high frequency diode, I want to say one example which was useful for rectifying a low frequency also, which was manufactured for high current capacity. That diode was called as BY127. It was a very good diode. B means silicon. Silicon diode, high current, 1 ampere current rating, high voltage, that is 300 volts can be rectified using this. Whereas 4002, 4007, 4002 can be only for 50 volt. Like that, B127 is a very good thing. It was manufactured by Bharat Electronics Limited in the year 1970. For example, I am telling this. And then moving on from high frequency diode.